Imagine everything you've ever understood about reality. Every particle, every force, the very essence of existence being shattered in a single, mind-bending revelation. For centuries, we've built our understanding of the universe on the bedrock of classical physics, a world of predictable motions, solid objects, and a reality that exists whether we observe it or not. This framework has guided us from the orbits of planets to the circuits of our computers, a foundation so solid it feels like truth itself. But what if that foundation is an illusion? What if the universe, at its deepest level, operates by rules so strange, so counterintuitive, that they defy our every instinct about what's real? Quantum mechanics, the science of the subatomic, has been quietly unraveling our assumptions for over a century. But now, new experiments and discoveries are pushing us to the edge of a paradigm shift. They're revealing a cosmos that's not just bizarre, it's fundamentally unlike anything we've ever imagined. Buckle up, because this is a journey into the heart of reality itself, one that will leave you questioning, awestruck, and forever transformed. Let's begin with the stakes. Our everyday experience tells us the world is solid, dependable, a place where objects exist in definite states, moving through a universe governed by clear cause and effect. A ball rolls down a hill, a star burns in the sky, and time marches forward in an orderly line. This is the world of classical physics, a story so intuitive, it's woven into the fabric of human thought. It's the lens through which we've built bridges, launched rockets, and mapped the cosmos. But beneath this familiar surface lies a realm so alien it challenges the very notion of reality. Quantum mechanics, the science that governs the behavior of atoms and particles, reveals a universe where certainty dissolves, where particles can exist in multiple states at once, where observing something changes its very nature. For decades, we've known this strange world exists, but recent experiments are taking us deeper, showing us that the quantum realm isn't just a curiosity. It might hold the key to understanding the true nature of existence. The implications are staggering, shaking not just science, but the way we see ourselves in the cosmos. To grasp why this matters, let's step back to the origins of quantum mechanics. In the early 20th century, scientists began probing the subatomic world, expecting to find a miniature version of the classical universe, tiny particles behaving like tiny billiard balls, following predictable paths. But what they found was utterly baffling. Particles like electrons didn't behave like solid objects. They acted like waves, spreading out across space, existing in a haze of probabilities until measured. This was the birth of quantum superposition, the idea that a particle can exist in multiple states simultaneously, here and there, up and down, all at once, until an observation forces it into a single state. Then came entanglement, a phenomenon so bizarre it defies comprehension. Particles separated by vast distances can become linked, so that measuring one instantly affects the other, as if they're communicating faster than light. These discoveries weren't just odd. They were revolutionary, suggesting that reality at its smallest scales operates by rules that mock our intuition. Yet for years, these ideas were confined to the realm of the microscopic, a quirky footnote to the real world we could see and touch. But now new experiments are showing that the quantum world might not be so separate after all. Here's where the story takes a breathtaking turn. Scientists have long assumed that quantum effects, superposition, entanglement, the uncertainty of particles were confined to the subatomic, fading away as objects grew larger. The classical world, they thought, was immune to these peculiarities. governed instead by the predictable laws of Newton and Einstein. But recent experiments are shattering that assumption. Researchers have pushed the boundaries, demonstrating quantum effects in objects far larger than atoms, molecules, even tiny crystals containing trillions of particles. In one groundbreaking study, scientists placed a sapphire crystal, visible to the naked eye, into a superposition of vibrating and not vibrating at the same time. Let that sink in. An object you could hold in your hand, existing in two states at once, defying the very notion of a single, definite reality. This isn't just a lab trick. It's a glimpse into a universe where the line between the quantum and classical worlds is blurring, where the strange rules of the subatomic might govern everything, from the smallest particle to the largest star. The revelations keep coming. Another cornerstone of quantum mechanics is the phenomenon of wave-particle duality, the idea that particles like electrons or photons can behave as both particles and waves, depending on how we observe them. This duality lies at the heart of the famous double-slit experiment, where particles fired at a barrier with two slits create an interference pattern, as if they're waves passing through both slits at once. But when you measure which slit a particle goes through, the pattern vanishes and the particle behaves like a solid object. It's as if reality changes based on whether we're watching. For decades, this was thought to be a quirk of tiny systems, but recent experiments have scaled it up. Scientists have observed wave-like behavior in molecules containing thousands of atoms, molecules so large they're closer to a grain of sand than an electron. These findings suggest that the quantum world isn't just a hidden underlayer, it might be the foundation of everything we see, a reality where observation shapes existence itself. The universe, it seems, is far more fluid than we ever imagined. But it gets even stranger. Entanglement, that spooky connection between particles, is proving to be more profound than anyone anticipated. In recent years, experiments have confirmed entanglement across distances that defy belief. Particles separated by hundreds of miles, even across time, behaving as if they're part of a single unified system. One experiment entangled photons in a lab with photons from a distant star, light that left its source millions of years ago, suggesting that quantum connections can stretch not just across space, but through the vastness of time itself. Even more astonishing, researchers have begun exploring whether entanglement could underpin the fabric of space itself. Some theories propose that the very structure of the cosmos, space, time, gravity, might emerge from a web of entangled particles, a cosmic tapestry woven from quantum threads. If true, this would mean that the universe isn't just influenced by quantum mechanics, it's built from it, a reality where every star, every galaxy, every moment is a manifestation of quantum entanglement. Now let's pause and feel the weight of these discoveries. These aren't just abstract ideas or mathematical curiosities. They're a direct challenge to our understanding of what's real. If quantum effects can persist in objects we can see, if entanglement can connect particles across space and time, if observation itself shapes reality, then what is the universe? Is it a solid, objective place, or a fluid, ever-shifting dance of probabilities? The deeper we probe, the more the cosmos seems to whisper, "You thought you understood me, but you don't." This is a moment of reckoning, not just for scientists, but for anyone who's ever gazed at the stars and wondered what it all means. The quantum world isn't just a strange corner of physics, it's a window into a reality so profound, so alien, it forces us to rethink our place in existence. And as we stand on this precipice, the possibilities are as exhilarating as they are unsettling. What could this mean for the nature of reality? If quantum mechanics governs not just the subatomic, but the entire cosmos, we're forced to consider ideas that stretch the limits of imagination. One possibility is the many worlds interpretation, a theory as breathtaking as it is radical. It suggests that every quantum event, every particle choosing one state over another, splits the universe into parallel realities. Picture it, every time a particle is measured, the cosmos branches into countless versions, each containing a different outcome. In one universe, the particle goes left. In another, it goes right. In one universe, you're reading this script. In another, you're halfway across the galaxy. This isn't science fiction. It's a serious hypothesis, grounded in the mathematics of quantum mechanics. The massive galaxies we see, the intricate structures of the cosmos, could be the result of countless branchings, a multiverse where every possibility plays out somewhere. The quantum experiments we're conducting might be glimpses into this infinite tapestry, a reality where every choice, every moment, spawns a new universe. But there's another possibility, one that's even more mind-bending. The relational interpretation of quantum mechanics suggests that reality isn't absolute. It's relative, defined by the interactions between objects. In this view, a particle doesn't have a definite state until it's observed, not because it's in some vague superposition, but because its properties only exist in relation to something else. The universe, in this model, is a web of relationships, a cosmic dance, where nothing is real on its own. Everything depends on everything else. The galaxies, the stars, even you and I, are defined not by our individual existence, but by our connections to the rest of the cosmos. This idea resonates with the findings of entanglement, suggesting that the universe is a holistic, interconnected whole, where every particle, every event, is part of a single, unified reality. It's a vision of existence that's both humbling and poetic, a cosmos where separation is an illusion, and everything is bound together in an eternal embrace. Then there's the quantum information hypothesis, a concept that pushes us even further into the unknown. Some physicists propose that the universe isn't made of particles or waves at all. It's made of information encoded in a quantum code that underlies everything. In this model, reality is like a cosmic computer, processing information to create the illusion of space, time, and matter. The strange behaviors we see in quantum experiments, superposition, entanglement, wave-particle duality, could be the rules of this computational framework, the syntax of a universe programmed at its deepest level. The galaxies we observe, the black holes, the very flow of time, might be emergent phenomena, like images on a screen, generated by lines of code. This idea, while speculative, is grounded in rigorous theories like quantum gravity and the holographic principle, which suggest that the universe's information is encoded on a lower dimensional surface. If true, it means we're living in a reality that's more akin to a simulation than a physical world, a cosmos where the boundary between reality and illusion dissolves. And if that's not enough to shake you to your core, consider this. What if consciousness itself plays a role in shaping reality? The observer effect, where measuring a quantum system alters its state, has long puzzled scientists. Why does observation matter? Some theories, though controversial, suggest that consciousness might be integral to the quantum world, that the act of observing doesn't just reveal reality but helps create it. In this view, the universe requires conscious observers to bring it into being, a cosmos that's not just physical but participatory, shaped by the minds that perceive it. The galaxies we see, the stars that burn, the very fabric of space and time. Could they exist because we're here to witness them? This idea, while on the fringes of science, resonates with the strange, observer-dependent nature of quantum experiments, hinting at a universe where mind and matter are intertwined in ways we can't yet fathom. As we grapple with these ideas, one thing becomes clear. Quantum mechanics isn't just a scientific theory, it's a gateway to a new understanding of existence. These experiments, from superpositions in crystals to entanglement across cosmic distances, are tearing down the walls of our classical worldview, revealing a reality that's stranger, more interconnected, and more profound than we ever imagined. Whether the universe is a multiverse of infinite possibilities, a web of relationships, a cosmic computer, or a participatory reality shaped by consciousness, the truth is out there, shimmering in the strange behaviors of particles and the vastness of the cosmos. These discoveries are a call to adventure, urging us to dive deeper into the mystery, to embrace the uncertainty, and to marvel at the sheer audacity of existence. So where do we go from here? The quantum revolution is just beginning. With every experiment, every new insight, we're peeling back the layers of reality, uncovering a cosmos that defies our expectations. The particles we study, the entangled systems we probe, are like cosmic breadcrumbs, leading us toward a truth we can't yet fully grasp. The universe is under no obligation to make sense to us, yet, in its strangeness, lies an invitation to explore, to question, to dream. Is reality a single, objective truth, or a kaleidoscope of possibilities? Is it a web of connections, a computational code, or a canvas painted by consciousness? Or is it something we can't yet conceive, a truth so profound it will redefine everything we thought we knew? The answers are out there, encoded in the dance of particles, waiting for us to find them. This is more than a scientific journey. It's a voyage into the essence of existence itself. Quantum mechanics has opened a door to a universe that's wilder, weirder, and more beautiful than we ever imagined. And as we stand at this threshold, one thing is certain. The story of reality is far from over. It's a tale of wonder, of mystery, of endless possibility. So keep probing the unknown, keep chasing the truth, and keep marveling at the cosmos. Because the universe is calling, and its secrets are waiting to be unveiled.